I can hear you.
So you can adjust your webcam accordingly, and yeah, you can do the setting before we start.
अनेबल तो है, आपकी आवाज नहीं जा रही उनको.
हाँ सर, we can hear you. Hello.
94366
30
596.
Okay sir, we can hear you sir. Hello.
Yeah, can start.
Hello.
Start reading.
943330593
596.
596.
Sir, I can hear you sir. Can you hear us? Hello.
उनको बोलिए कि कुछ लॉक तो नहीं कर रखे हैं.
Hello.
Please.
हाँ sir.
Now I am in. I can see you. Okay, fine. So my PPT is there.
Introduce you sir.
Yeah, just he will introduce. Dear participant, good afternoon to everyone. Today we have our second session. So I request organizing secretary to introduce the speaker.
Okay, good afternoon to all. All the participants. Now we are going to hear from a eminent speaker, Dr. Ishwar Chandra Das, who is the scientist SG and head HSD National Remote Sensing Center, Indian Space Research Organization, Hyderabad. So now I introduce and just I'll go his brief biodata. So Dr. Ishwar Chandra Das completed his MSc MTech degree in applied geology, so from Indian School of Mines, Dhanbad, in 1993, and MSc in geological survey from ITC Netherlands.
Hello.
So and got his PhD from University of Twente and ITC Netherlands. So he is working as the head hydrology division of National Remote Sensing Center.
Can you people hear me?
Hyderabad, presently leading a team of scientists. Yes, sir, I can hear you. Just I am just going through your biodata to all the participants. So, in 28 remote sensing centers across the country to carry out groundwater prospects and quality mapping. He's not able to. Sir, we can hear you and we can see you, sir. We can see your PPT.
So then we can start the lecture. Okay, but I am not able.
हाँ, मोबाइल से सुन रहे सर, उसमें नहीं आ रहे, इसलिए मैं बता रहा हूँ सर. मैं वही बता रहा हूँ, उसमें मोबाइल से सुन रहे.
Sir, actually, whatever we are hearing, we can hear your voice. Please unmute, sir, and you can hear it.
We can see your slides also, sir.
Sir, we can hear
you.
you.
Able to hear them.
You may be muted in your computer. Can you check it, sir?
Okay, yeah.
You might have muted your speaker.
Now I can hear you and everything is fine.
Okay, sir. Let me start from the beginning. Actually, yeah, I requested Dr. Patnaik to introduce the speaker. Dear participant, there was a technical problem. He will be introducing the speaker. Dr. Patnaik, please.
Okay, Dr. Ishwar Chandra Das is currently working as a scientist SG and head HSD in National Remote Sensing Center, ISRO, Hyderabad, and he has completed his MSc Tech in Applied Geology from Indian School of Mines, Dhanbad, and he has got his MSc in Geological Survey from ITC and also PhD from ITC Netherlands, and he is now currently working as a head hydrology division of NRSC, ISRO, Balanagar, Hyderabad, presently leading a team of scientists in NRSC and scientists in 28 remote sensing centers across the country to carry out groundwater prospects and quality mapping, which is also a part of, you can say, in forestry also. Forests is a lot of scope is there, and he is currently the project leader of National Drinking Water Mission for targeting groundwater and rural drinking water supply in India under Rajiv Gandhi National Drinking Water Mission project. He has specialization in geomorphology, structural geology, groundwater exploration, and spatial modeling using remote sensing and GIS. He worked in NRSC and ISRO for 24 years, mainly involved in imparting training, research, consultancy, and projects in groundwater. Published more than 20 research papers in national and international journals of repute, and he has also authored more than 50 reports on groundwater potential mapping for site-specific studies. He is an expert committee member, Minister of Water Resources and Minister of Drinking Water Sanitation, Government of India. He is the reviewer of many international journals, and he received ISRO Award for Group Excellence in the field of groundwater mapping. So today we are fortunate to get him as a speaker, and we are eagerly waiting for his lecture. Thank you all participants. Now we will attend his lecture. Please, sir. Sir,
Thank you, Dr. Patnaik, for introducing me. Actually, can you see my PPT in the
yes.
slide mode?
Yes.
Okay.
Yes.
Yeah, no, slide mode is not a view, sir. You can click on the slide mode.
You can click on the slide mode, sir.
Slideshow view, you can click on.
Yeah. That's what actually I am trying to do. You know that initially this Zoom is not allowed in the ISRO centers, maybe little bit of problem. So I'm working with a laptop, so I'll try. Maybe it is. Is it now okay? No, slide
sir,
mode has not come.
We cannot see. Has not come, sir. But your slides you can see.
Sir, slide view, you can view this slideshow. Sir, slideshow, you can go to slideshow and then click full view.
That is what the problem is happening. 1 minute.
Okay, sir, we will wait.
So 1, 2, 3. Sir, from the file row, you can see that slideshow, and there you can click, sir. It will come.
Okay. So, I mean, in the meantime, I would like to give a small briefing what exactly I am thinking and planning. See, basically, the groundwater resources basically is in the country, not only in India, but if you see that groundwater is being used as a resource for drinking, irrigation, recharge, because it is the cheapest source or the easiest source to find. So the challenge that we are facing is enormous in the country. Why? Because if you look at the world statistics, what we are finding is that groundwater is being managed very nicely in all the advanced countries like Europe and US. And groundwater, in this my entire talk, I'll tell it is not only what we think of the groundwater as a resource, as a water component, but it can really hamper or it can influence the Earth's temperature also. So the point that I want to make is, you see, if we look at world statistics, then groundwater usage is very minimal in Europe, that is around 19%, and in US is around 24%. Even Europe and USA, the so less. In China also, it is around 25%. So the overall groundwater usage, people say that China and United States together, they are using less groundwater than what India uses. India's now present usage of groundwater is at 58%. So that means if we consider the country, forget about runoff zones, Himalayas and other hilly terrain, the usage of groundwater is very, very high. But who is creating the source? You see, you all know rainfall is the major source of all the water resources, whether it is surface water, whether it is groundwater. That rainfall, if it is not percolating into the earth or it is not conserved in a structure like dam or reservoir, then obviously it will either evaporate, evapotranspiration will be there, or it will be a runoff component. So if you look at the statistics of the water resources that are in India, you can very well know that there are around India has a 4,000 billion cubic meter of rainfall. Oh, please.
Yes, sir. Just a minute. I'm telling you. हाँ sir. Actually, just a minute. It is stuck. Yeah. Now it will come. अभी करिए F5 करिए.
Click that slideshow view.
दबाइए.
नहीं.
वो तो नहीं.
Yes.
Now it is okay, sir. Okay, sir. Okay. Please.
Okay. Thank you. So this is the water resource of India at a glance. If you look at the annual precipitation that is happening over entire territory of India is around 4,000 BCM, billion cubic meter. Out of that, you see more than 53%, around like 21-31 BCM is going as evaporation, or it is going to the recharge. So average annual potential flow in rivers is around 1869, but estimated utilizable water resource is around 1122 BCM only, because there are something which even if you want to stop, but it will go as a kind of extra water flowing into the ocean or the river during flood. Now, if you look at this 1122 BCM, surface water is 690 and replenishable groundwater is 432. Now, we only talk about this 690 and 432 because you see India's geographical area, you all know 328.73 million hectare, and almost that 40% of the country, it is the net cultivated area is around 140 million hectare, and irrigation area is again some 40% of the total area. So you have a capacity to increase the irrigation, at the same time to manage your water resource in a sustainable way. That is where now today's talk all around, and I will tell you how it can work. So coming to the hydrological uncertainties, why I am coming to this part, because climate and weather, they play a major role in the water resource of the country. You know, many years it is a drought year declared by the states, because India is the combination or the country of so many states. When the Ministry of Agriculture, Central Groundwater Board, when they have looked at the water resource availability, groundwater availability, if you look at the middle map, Ministry of Agriculture has given a drought index This middle map of India is showing, you can see 2 by 5, 1 by 3, 1 by 5, such kind of letters are written, though that legend is not very much visible. But this 2 in 5 means twice in 5 years there is a drought. 1 in 15 means it is once in 15 years there is drought. So when you look at our the 7-8 states of northeastern region, you can see drought is not very much there. That means environment is still little preserved. Climate change has not much affected the water resource in that particular area, because hydrological drought is coming only once in 15 years. But time is not far, that because I have visited many parts of the northeastern states where we have seen in the summer the water table goes down, springs get dry. So getting water is really a difficult proposition, and many places we have also gone for searching the water resource. If I look at this particular slide, it is our, it is analysis endeavor. The groundwater for the entire country we have done. We took 15 years. This program was run for 15 years from 1999 to 2014. An entire database is now put in our Bhuvan geoportal. So the advantage of this is you can see different colors in the map. All these colors, they are basically indicating the potential or the prospect. You can see a legend on the right side. This right side legend is basically indicating the kind of water availability in this particular zone. Now you see the Indo-Gangetic plain, where the water availability is very good, groundwater, more than 800 liters per minute. So it is violet color is there. But particularly if you look at the northeastern region, their potential is very low because the area is hilly, runoff is very high. That's why the groundwater potential of those areas are very limited. Then what we do? Alternatively, we have to look at the springs, because when whatever water is percolating into the rock strata, at some point they are coming out. But again, those springs, because of the nature of the change in the rainfall, temperature condition, or the human interference, those springs are getting dried up. In some springs, discharge has drastically reduced, and the perennial springs have become seasonal. So we need to categorize those springs into the dead or dried springs. One is seasonal and third is perennial. See, those which are dried off, dead, we need to rejuvenate them so that the water will again oozing out from those springs. Those which are seasonal, we wanted them to be perennial, or if they are perennial, we wanted them to maintain the kind of discharge we expect so that it can support our requirement of either irrigation or drinking or whatever purpose. Now, you know, just 2 days back, I had a meeting with our Arunachal Pradesh State Remote Sensing Center Director, Mr. Datta, and his scientists there. For the Itanagar, this urban area, they wanted to have a 1:10,000 scale, very high resolution groundwater potential mapping and source finding. And now we are laying down the methodology to be followed, particularly in a hilly terrain and the kind of challenges they face. So different area will have different potential. To tap those potentials, we have to work in that direction. We have to consider the geospatial modeling of different factors which are controlling the groundwater movement. That I'll also explain it. But coming to this kind of potential mapping we have completed for the entire country, I will little show you also in my presentation those slides how they are shared in the Bhuvan geoportal. Similarly, another gigantic effort we have taken in mapping the water quality of entire country. Now we have collected 7.8 lakhs of sources, and we have analyzed 8 to 10 essential geogenic parameters. I'll very precisely say geogenic because anthropogenic bacteria and all analysis and their movement is quite another challenge. But looking at the arsenic, fluoride, iron, nitrate, pH, all these factors we have looked at for the entire country. One of such map I am showing, that is fluoride contamination of the groundwater in different parts of the country. This is one is pre-monsoon, another is post-monsoon. As you all know, the 1.5 milligram per liter of fluoride, more than 1.5 is considered non-potable in India. You will have dental fluorosis, you will have skeletal fluorosis. Now, using our geospatial modeling, you see it has very clearly come out that which are the areas. I'm in a lecture. In this particular endeavor, you can see the red ones means they are non-potable areas. And the yellow ones are in the permissible limit and green are the desirable. Now see, using this geospatial modeling, it has come so nicely. Some part of Rajasthan mainly, lot of fluoride issues are there. Madhya Pradesh, Maharashtra, Telangana, Karnataka, Andhra Pradesh, Tamil Nadu, they are the major. Then you have UP, the major affected areas for fluoride contamination. Though in the northeast region, it is very sporadic and occurs in patches. Similarly, you have the arsenic contamination map we have generated using the entire country data, and we found nicely that there are issues in Punjab, Jammu Kashmir, then in UP, then Bihar, West Bengal. Yes, there are problem of arsenic in many states of Northeast. You can see Tripura, you can see Meghalaya, you can see Assam. There are many issues of this arsenic contamination of groundwater in those states. And especially in Arunachal Pradesh, when I discussed with my colleagues from the Arunachal State Remote Sensing Center, they told, sir, here iron is another problem. Very high iron content they are finding, and few places only fluoride. But the water content, though iron contamination is not fatal, but it can lead to some kind of indigestion, stomach acidity, and other problems. So we overall, the point here is we have the entire geospatial database for groundwater quality data points of more than 8 lakhs. We have a prospect mapping which is done at 1:50,000 scale using least 3, that is 23 meter data. So we have restricted it to 50,000 scale. But after the decade, after 2014, we got a lot of requests that, sir, in few areas there are acute problem where in this 50,000 scale mapping we are not getting the minor features of groundwater resources, so that at village level planning we are facing little difficulty. Now we have launched last 3 years back a program, groundwater source and sustainability mapping on 1:10,000 scale for the areas where we have a problem like drought affected areas or the hilly areas where we have problem, we can go for 1:10,000 scale mapping. And one of such endeavor is now the Arunachal Itanagar, that is Itanagar urban area, entire 50 square kilometer area we are planning to map in 1:10,000 scale. So the issues that I have already described to you is water resource development and potential. You see, if when I talk about the potential of water resource, because India is a country of unity in diversity, if you look at this World Resource Institute WRI map, see the Eastern India basically comprising of Bihar, Jharkhand, Chhattisgarh, Orissa. These are the states where irrigation has not gone to the level where the South and Western Indian states have reached. As a result, the groundwater development in these states is far less, around 25 to 30%. So, Government of India has started one program in which we are also making our technical knowledge, we are sharing that, bringing green revolution to Eastern India. That means during the Kharif season only there is agriculture in Eastern India, which is rain fed. But after the rainy season, there is patchy agriculture happening in the Eastern India, but not the extensive second crop, Rabi crop that is happening. That means here the potential is there, but maybe people are poor or their thinking process has not reached to that level that they are ready to extract water in this second Rabi season crop. So that means we have a potential, but that need to be used. So water efficiency, water use efficiency also one of the very important factor in the irrigation, you all know, because some places we are going for a flood irrigation in agriculture, and like paddy, sugarcane, where a lot of water goes as wastage as the evapotranspiration is very high. So coming to the integrated water resource management, what we basically NRSC do a earth observation, remote sensing based application, rainwater harvesting. We talk about watershed development. We talk about river basin development, interlinking of rivers, groundwater targeting, command area development, all the gamut of activity which is coming as an integrated water security system. It is basically remote sensing plays a very, very important component and role in the forested watershed management, all the kind of activities, snow and glacier, climate change. So remote sensing has its own role to play in the entire process. So what basically I told you, we have to map the availability, the quality of surface and subsurface water, measure and understand how the water cycle varies and changes, predict how the availability and the quality of water resource will change on a range of time and space, support the integrated planning management of waters. Now here I would like to bring you one point. I was in Netherlands for quite a long time. I wanted to understand their scenario of water resource. You know, Netherlands is a country where 35% of the area is below mean sea level. And the groundwater, because there is a sea surrounding the stretch of western coast, the groundwater, that is the fresh groundwater, is very thin. It is around 6 to 8 meter of fresh water only. Below that, all saline water. But those people, to maintain that 6 meter of groundwater, they are injecting fresh surface water through injection wells along Rhine River, and also at the same time extracting same amount of water from the ground. so that they maintain the water table. Why the water table maintaining is very important? You people all know when we went to a forested area, a greenery, obviously during a summer time, we feel cool. Why? Lot of trees, shadows, but at the same time, you look at the soil moisture. Now we are doing the research on a GRACE satellite, a gravity satellite, and there are many radar, this one SAR data processing as a soil moisture. So if you understand if soil moisture is very high, then what happened? As you know, evaporation causes cooling. So as the soil moisture is extracted, it brings coolness. So it is invariably many places you can see where the groundwater table is shallow, this area temperature also will be little less. So that means the groundwater resource is contributing to the global temperature change, global rise in the temperature. And one more research on this groundwater, I'll tell you, that was in a 2009 published in the Nature. The people in US, what they are claiming, the high intensive agriculture, that is irrigated agriculture, groundwater irrigated agriculture happening in the Indo-Gangetic plain is exploiting so much of groundwater, and at the same time, because of the paddy cultivation, flood irrigation, lot of water is flowing into the sea, Bay of Bengal, finally contributing to the sea level rise. That also is coming in that paper and showing that this is also contributing to the global climatic scenario. So groundwater, we can do surface water resource assessment. My colleagues are doing. We are doing groundwater resource assessment. Groundwater resource assessment in many priority area we do to understand how much exploitation or extraction it can support. There are basically two major methods. One is we look at the pre-monsoon, post-monsoon water level change. We call it groundwater fluctuation method, or rainfall infiltration factor method. That is how much of rainfall is incorporating into the underground, and so that in the monsoon water table is coming up. One point I would like to emphasize in India, because it's a monsoonal country, we get entire 70 to 75% of our rainfall is between June to the September-October period. So you can say out of 12 months, we get rain in 4 months, that too maybe 60 rainy days, whereas it longer or its uses is for 365 days. Now imagine if you earn 2 months your salary and you eat it for the entire year, what will happen? Obviously the resource is going to deplete whatever earning you do. So to make the water resources sustainable in our country, the Ministry of Jal Shakti, they have taken an abhiyan, that is Jal Shakti Abhiyan, to conserve water at every village level. Because whatever amount of rainfall happening in your village, if it stays for more time in your village, then obviously it will make your soil wet, it will allow the water to percolate downward, and finally all this water will help you later on when the monsoon, post-monsoon period, you will be helped. So obviously the planning of water conservation has taken a front seat now. Everybody is now thinking about the water resource conservation groundwater resource assessment, surface water resource assessment. So all these have been extensively addressed by NRSC ISRO in different form. Like we have a water resource information system which is being developed by ISRO and CWC, Central Water Commission, and all the informations are put in that website India Waris. I will also tell about that. Now coming to the spring shed, the springs that we are basically talking about, where and how a spring forms. If you look at this picture, you have a porch water table. That means we have a isolated water body below the earth surface, and there is an opening. So through that opening it is coming. Now, how long it will come? Until that source is available. But if you exploit the source very fast, then spring will dry down in months. I have seen many springs. Basically, I have extensively worked in Uttarakhand. I was in Dehradun for 16 years. I served there, and we have extensively surveyed in the Himalayas. Many springs, if you go after monsoon, rainfall is very high in the Himalayas. In Dehradun, Mussoorie, 3000 mm of rainfall like the northeastern region. But when the time March comes, there is a drinking water problem in Dehradun. Then April, May, there is severe drinking water scarcity of water. Why? Because it's a slopy condition. Water is allowed to pass through. It has gone to the Bay of Bengal. No, water is not staying with you. So how to conserve? How to make it sustainable for a longer period? We should think on that. So there the role of geology and geomorphology come. Geomorphology, looking at the terrain condition, the topography, the behavior of the stream beds, stream flow, stream material, whereas geology more tells about the rock types, their character, porosity, permeability. So the problem, if we understand in the perspective of hydrogeology technically, then water has to be, understood, their flow direction to be understood, and finally it will be a very good case study. How? See, when we talk about watershed, we know we have to demarcate the water divide areas. But here, springs are more controlled by the layers, the rock layers, and their attitude, means their bedding. So I will slightly emphasize on the structure of the rocks to understand how the springs can behave in these hilly terrains. And what we are telling, spring shed management follow a valley to valley approach. That means instead of looking at a watershed, a boundary of hill, we have to look at one valley to the another valley, and the attitude of the bedding or the rocks which are controlling the spring movement. Hydrogeology is key to identify the aquifer and the recharge area. Why? Because until and unless we understand the geology of those rocks, their character, their porosity, their volume, the voids, their connectivity of the voids like permeability, we need to understand them in the field to make an assessment of the spring and their discharge. So recharge and discharge area fall in the boundary of two different villages. Those kind of problem may come. Effective spring shed management entails cooperation between both villages. Sometimes what happened, you may feel on the surface it looks different, but when you go to subsurface, things are different. That's what we need to understand, that surface feature, if only we consider hydrology, surface flow, stream, we may not exactly characterize the spring set. We have to look at the geology, the properties of the rock, the morphology, the bedding attitude, their structure, all these features we need to look at. So you see, a effluent influent condition I am just showing means here if you look at the top figure, from the underground water is recharging the stream. That's why their effluent stream means they are perennial. Because groundwater is feeding to the stream, they are becoming perennial. So in our case, also in stream set, we have to see that continuously there are some underground water source which need to feed the spring to make it perennial. But otherwise, your second condition down below, you can see influent stream. That condition will come. Your stream bed is high above the water table, and whatever water available in the stream bed, it will percolate down and the stream will be dry. So your spring will be dry. That means we need to maintain a water table in the hill itself, which will replenish the springs so that it will sustain, and its discharge also will give us continuously feed. This is one small statistics from our mapping. As I told you, I have shown you in the groundwater prospect mapping. This is the statistics that we have collected by looking at some field observation. On 50,000 scale, there will be many more springs. I am not trying to defend that these are the figures, but these are the locations our field people have collected during that 50,000 scale mapping, because we have gone to a 50,000 scale with our least 3 satellite data, and this is the spring count we got in different states. This can be a beginning to start with, to understand the nature of the spring set. Now more I will put some light on the spring. See, these are the spring locations of Uttarakhand. Though we have similar spring inventory for entire country, we have also all the states. Here I am trying to show, because I have extensive field experience in Uttarakhand. If you look at this MCT MBT line, if you look at, there is a MCT line, there is a MBT line. In between, you see 75 to 80% of the springs are basically located within that line. Why? Why so? Because between the MCT and MBT, it is the meta-sedimentary rocks of Himalaya which is coming from the Tethys Sea. You must have heard there is a shallow sea, Tethys, in the region where Himalaya is, because of the crustal movement, Indian plate crumpling under the Eurasian plate or Tibetan plate, Himalaya, a folded mountain belt is formed. Similarly, your Himalaya up to Arunachal, then the Arakan Yama range going up to Myanmar. So the entire hill range that is formed because of the Indian subcontinent moving below the Tibetan plateau, making a folded mountain belt. But what is the significance? In these folded mountain belts, I have my detailed understanding that the meta-sedimentary rocks like schist, phyllite, grey-wakes, they are interbedded, and all these interbeddings have different porosity and permeability, and also there are many local and regional faults. So the springs, that is the subsurface water in the form of springs, has oozed out in many of these places, many of the villages. Their source is either for irrigation or drinking only springs. I think you will all agree in the northeastern states also such kind of scenario is being seen, that many of the villages there is no major river, there is no major stream. The source of drinking and irrigation is through springs. So now you see so many springs in this entire stretch, and rainfall is very good. Why not we try to conserve? Because as you people have a forestry background, you know that forest cover is degrading in the Himalayas, and because of that, the water percolation into the soil and underground rock has decreased. So many of these springs are dried. I will give a simple example of my experience. You see, Himalaya is coming east to west. Since we are in northern hemisphere, sun goes from east via south to west. So southern slope of Himalaya, always you feel they are illuminated by sun. Majority of those southern slopes you find agriculture, because there is sun illuminated, lot of sunlight will be there. But the springs are more in the northern slope, because northern slope is shadow. You get lot of forest, lot of dense forest in the northern slope of Himalayas. That means in the northern slope also you find lot of snowfall when it happens, more snowfall in the northern slope. And because they are not getting direct sunlight, that snow in those areas also can continue for 15 days, in a month, they stay, slowly it melts. So that slow melting process will also give a good recharge condition into the soil. So northern slope of Himalaya is highly vegetated, whereas southern slope is barren, because lot of sun facing, soil moisture is not retained, and because of that the recharge condition is less. This is comparative. So the comparative, am I audible?
Audible, sir, audible.
Okay. So comparatively, the northern slope of Himalaya is more vegetated, and you will have more springs in the northern slope than the southern slope. You take it Himachal, you take it Uttarakhand, Jammu Kashmir, even in Nepal, then Sikkim and Arunachal Pradesh, you will find similar condition. But because of the change in the direction of the Himalayas and Arakan Yoma, that is in Arunachal and the northeastern states, the ridges are north-south trending. So they get equal sunshine, because east and west slopes, they get equal sunshine in a day. So you will not have that much of variability as you see in this part of Himalayas. So that is also one of the reason of springs being more, seen in these northern slopes, and they are also sustainable, because there is rainfall, there is snowfall, which both are contributing to that. This is a kind of recharge plan in the spring set. That means you have to make the terraces, you have to modify the slope. That's what I was telling. Your entire rainfall, if it is not harvested, not conserved, it will flow down to Bay of Bengal. And as much as possible, if you conserve, then what happens? It will stay there for a quite some amount of time, And these kind of practices are very good in the forested areas, because first we need to look at the slope condition. And one more point I would like to tell you, when we are doing a spring shade management, I will go to a picture, then I'll come back to you. See here, the slope criteria is very, very important when we talk about a spring shade management. 0 to 2 degree slope is considered best for a recharge scenario, but in hills, getting a 0 to 2 degree slope is very difficult, very rare. Then next category is 2 to 5. 2 to 5 is the category which little bit you can get, not much. But 5 to 10 degree slope condition you may get in many places. So the point here is we have to make a slope class using a digital elevation model. You know, satellite is now giving digital elevation model. From that, if you make these classes and understand your area, then look at the slope condition. Then also spring shade rejuvenation and recharge will be higher. Whereas the slopes which are more than 15 degree, they will only contribute much to the runoff because of the high gradient. The water will move very fast and it may not stay much time in that particular zone. So slope is one of the major criteria that we need to consider when we are planning a spring shade or spring rejuvenation process. So obviously these are the ways and means along the contour. At a same particular contour or same height, we can make the trench or we can make small embankment so that water can stay for a longer duration of time. Now coming to this structure, as I was telling you, why a spring shade is more related to the geological structure. What geology plays a role in spring shade is, you look at this kind of structures and in the underground, on the surface, they may look flattish or even horizontal, but the rock attitude, the bedding attitude will control the movement of water, because along the contact of two beds, we get a weaker plane through which water can move faster. That is sin bedding movement. So if we have a sandy layer and a clay or shale layer, shale obviously impervious, then what happened? Whatever water is percolating in the sand, they will move along the clay layer and will try to ooze out along some fracture or the openings. So that means in this sandy zone, if we make a recharge measure, it will certainly allow the water to stay for more time. Soil moisture will be retained, rainfall water will be retained, snow melt water will be retained, and it will act as a good recharge zone. That's why the kind of folded structures that we see in Himalayas, in northeastern states, plays a major role in controlling the movement of water from the springs. That's why a detailed geological mapping is very much required to understand the kind of springs that is being seen in these areas. There can be different kind of folds. There can be syncline, there can be anticline, we call it, like these hills. There can be syncline, means a basin like hill. So there will be hills form of the basin rocks. Sometimes they are domal structure, but overall morphology, if you look at this hill photograph, even though it is a basin kind of structure, geological structure, but morphology is a hill. So it will act as a runoff zone. So those are very, very essential to understand or to get the maximum benefit out of a rejuvenation scheme, a recharge scheme, particularly in the hilly terrain. This picture again from Dehradun, obviously the similar pictures are also in the entire Siwalik region. This is one Siwalik photograph I am showing. Your Itanagar and Pasighat area is also comes under Siwalik only. And you will get lot of luxurious vegetation in Siwalik. Why? Siwalik is a rock formation in very recent age. In geological time scale, we call Pliomiocene. It is around 1,000,000 years, 1 to 5 million years of age. And these rocks are semi-consolidated. That means they are not very compact. There are pore spaces and they can be, their strength is moderate. So water can easily percolate into those rocks. You see in the hills, you can see so reddish tinge, that is the salt forest, which are very dense. So whereas you see the southern side, southern slope, the vegetation is less, as I have told you, because it's a east-west running hill, you will have more moisture retained in the northern slope, which allows luxurious growth of forest. Whereas in the southern side, you will have less vegetation. But you need to conserve all the hillsides. Water you need to conserve in this southern slope also, so that here also the trees will get more water and the forest will be restored. And for that, we need the hillside mapping, understanding the drainage pattern, understanding the spring present in those areas, and those exit points or outlets through which water is coming. So then again, so the point here is lot of vegetation. You can see reddish patches. You can see lot of reddish patches. The shal forest, especially in the Siwaliks. Then when you go to Himalayas, the redness has decreased. That means the density of vegetation is less. Obviously, Siwalik, as I told you, younger rock, soft rock, water holding capacity is more. So it is giving rise to a luxurious growth of shal trees. And you find this kind of vegetation in the sandy soil because they are all sandstone, Siwaliks mostly, then some clay layers, but those sandstones are very friable, very soft, holds good water. So you can very well differentiate the vegetation, nature, their density based on this kind of material which are present below the earth. This is one picture from the your northeast, like Arunachal Pradesh. Mostly you can see your Pasighat will be the bank of this river. You can see the red patches again. This is the Brahmaputra Valley, where a lot of cultivation takes place. Here the valley is a kind of intermountain valley in between two hills. So a lot of water is entering into the valley. That's why you get a lot of flooding activity, and you have luxurious growth of vegetation in Arunachal Pradesh and the northern Assam foothills. This is one of the picture from your northeast. Exactly, you have seen the other picture where the Himalaya, but here it is the tertiary of Assam, where you get this Arakan Yoma range. In that you get the tertiary rocks, that sandstone and shell, but orientation here is different. Basically north, northeast, south, southwest, or better you say north, south. So you see here that kind of variation in the vegetation is not much visible in terms of slope. So in Himalayas, the slope or the aspect rather, it controls vegetation. Whereas in the northeastern hilly range, it is not that much important, the aspect, but it is the rock type. Different rocks, they have different density. When you have shale, obviously water table is shallow, but water holding capacity is less. It will give different signature, subdued topography. If it is sandstone, it will relatively resistant, so it will give hill ranges. So such kind of variation you can see in the satellite image, then you can demarcate them to understand the hillsides and the spring sets. This is one of the close picture of those areas. The lithium cut prominent fault, that is Nanko silt fault and lineament. You see, you can see the lines. They are basically representing the cross cutting of two faults. So there are many faults in the northeastern region which are being studied, and they are also active faults. That's why you get also earthquake and other the neotectonic activities in those areas. The geodynamics of earth is very high in those areas. This is that Barak river in the Assam and part of Tripura. See, when the river comes from the hill to the plain areas, because the river bed load is unable to carry it away, and they make meandering. This we call meandering rivers and oxbow lakes. You can see there are oxbow shaped lakes which are cut off from the main river, and we can also see the paleo bank of the river, which is paleo levee, we call it in a floodplain. That means river has shifted from one place to another quickly. In Indo-Gangetic plain, you find lot of shifting, even 50-60 kilometers together. The river has shifted because it's almost flat, 0 to 1 degree, even sometimes 0 degree, almost flat. But because of the little slopy condition in this area, we don't find that much of shifting of the river, but the river shifting is very much visible in this satellite. And this is what I have told you, the north-south ridge that we see in the northeastern hills. You can see the alignment which is north-south, whereas Himalayas, it is east-west. And similarly, we can have a kind of alluvial fan. This is one alluvial fan. When the river comes from the hill to the plains, lot of springs also you will find. There is one place near Dehradun, Sahasradhara. There are thousands of springs in those areas. Now they are though dry, few are left, but you get sometimes in the foothills lot of springs coming and rejuvenating the river. Such kind of scenarios are also possible. Now coming to this spring set, see what I told you in the beginning. I have shown you the picture. We have to take a valley to valley concept. Here, the ridge line is this dash dash line. That means if we consider a watershed in a hill, for rejuvenation of spring, we may not do a proper science, but we have to take the boundary that is valley to valley, means from one stream to another stream. So then in that case, what happened? We have considered the entire gamut of the geological structure, the behavior of the rock or the attitude of those rocks, which direction they are sloping or dipping. So that's why we have to consider a area which is like from spring, from river or stream to another stream. But here you can see I have done a classification of the slope. You can see some pixels, brown color ones. They are basically the ones which are the slope below 5 degrees. So I have plotted the springs on the map, geological map, unblind nice, granulite nice, the rock types you can read. And in that particular rock condition, I am seeing which are the area which are not flat, because getting a flat land is a hilly terrain, very difficult, but relatively flatter, where the gradient is less. So this area, to rejuvenate a spring here, what I need to do? I need to look at these areas where the slope condition is less and it is in the upper reaches of the spring. So if I start doing some intervention here in terms of making recharge structure, pits, then contour bonding, or uh, check dam and all, then what happened? Village pond, if any village is there, it will obviously recharge the source of the spring, and certainly the spring discharge will increase. Or if the spring is dry, you will find after a year or so things are becoming better and better. So I need, why I am showing you this figure, I need to focus in that small zone, not the other areas where the slope is very high. If the slope is more than 15 degree, whatever interventions I do, whatever structures I make, either they will break by the heavy water flow, or they may not really recharging the my source of my spring. So that's why I told you aspect and slope, those two play a very major role while designing and planning a spring set. So different condition we need to see. Similarly, here you see, we see a spring. Near to the spring, there are less than 5 degree, 10 degree slope, flatter areas. So I should do whatever intervention in those, areas, not the any other areas where the slope is very high. So to have a proper planning, a GIS modeling is required, a geospatial integration of slope condition, geology condition, because slope condition is one factor. If there is a rock is very permeable, again it adds. So doubly it will be beneficial. That's why I have to look at if it is a structure. If there is lineament, fracture density in that area is more, it will more percolate. So if I go for a GIS data integration, then I will get that area where the feasibility is better and I get a good condition for the recharge of the spring, rejuvenation of the spring, so that in the entire spring set, this area is going to be targeted in the future. Though it is a forested watershed, but we have to look at the source and to rejuvenate the source. Similarly, here in the valley portion, you see more that gentle conditions are coming. So that means here using geospatial technique, I can identify the areas where geological structures are high, where the bedding is favorable, where the bedding is favorable, where the rock is favorable. Those areas I need to identify and understand them, their property, for a better planning of the recharge. This is the methodology. It's a not big thing. We have developed. We have a remote sensing input, because I told you so many input layers we prepare. We get a lot of field input, a spring inventory. We classify them, as I told you, whether they are dry, they are seasonal, or they are perennial. Then we have the different hydrogeological conditions like geology, geomorphology, structure, weathering conditions, soil, land use, land cover, slope. All these drainage water bodies need to be integrated to understand the hydrogeology, slope and aspect, then strata, their bedding attitude, spring set delineation, hydrology, the rainfall in those areas, the flow condition, and the land use. Together, when we do a analysis, then obviously we can map the spring set with suitability, and suggested interventions we can put on the map, and finally we come out with a implementation strategy for spring set development. So this is what the overall methodology that will lead to a understanding of spring set. Then you all know they are all springs. As I told you already, the springs are the primary source in many villages for drinking, irrigation, and livestock. But what happened? The demand has increased, land use has changed, people have gone for deforestation, for agriculture, for intensive agriculture. So the discharge has been reduced drastically. And you all know that initiative from Niti Aayog. Now also there is a committee for spring set rejuvenation and the spring mapping. Basically, it is looking at the Niti Aayog has taken up this activity for the entire Himalayas, and now the under this the CGWB and Ministry of Water Resource, they are forming a team of people living that Almora, the Himalayan that Mountain Environment Institute, Almora. They are also working on this. NIH Roorkee working extensively on the spring mapping and spring set rejuvenation. So now, because in the Himalayas there are lots of springs which were there once upon a time, presently they are dry, and the degradation of the Himalayan environment can be partially, if not fully, partly restored if the springs are restored. In NRSC, we are also started, working on it. We have taken some small spring sets. Will work in Uttarakhand. Then in the Nagaland, we have a plan to work in these two states initially. Later on, we'll move to other states. So the steps for implementation of spring rejuvenation can be, you see, comprehensive mapping of spring. That is obviously important. We have to look at how many springs, where it is, their location. Hydrogeological mapping of geoenvironmental factors, as I told you, geology, geomorphology, structure, slope, land use, lithology, all things need to be detailed mapping. And conceptual hydrogeological layout of spring set and modeling is also very important. Then recharge area, as I have shown you, which are to be put under recharge area, which to be left. Then the interventions that in the spring set you expect, then obviously when you do a intervention, you expect that there is an impact. So obviously you do a validation, then the impact analysis, and actually it is happening on the ground or it is just a knowledge that is shared. ISRO always shares because it is the vision of Vikram Sarabhai that space technology used for common man. That's why for a societal benefit, ISRO has completely dedicated. So wherever there are problems, we have gone, we have helped people all over the country to understand their problem, but at the same time, we handhold until they come out of the problem. So if you have a problem, we'll try to solve them, sort out them, we'll give the best possible solution in the condition that exists or that is in our hand. So this is all about the overview that I wanted to give you on spring set and spring set management. And I have a few slides on my project, which I have told you in the beginning. 1:50,000 scale, groundwater prospect and quality mapping. Can I mean, go to that, or you wanted a discussion?
Okay. Thank you, sir, for your excellent lecture. So I was also going through your lecture. So really it is a very good topic as far as the application of geospatial technology in forestry. And I was going through, actually we belong to here in Arunachal Pradesh. So also you see, if you'll see the conditions of your groundwater resource here. So we are not going to get, because Siang River is there, as you are showing some of the slides, the satellite picture. But we are not in our College of Horticulture and Forestry. It is just near to the river Siang, which is becoming Brahmaputra in Assam. But here we are not getting water, sir. So we have tried many tube wells, but many are failing. So the reason being that you are telling that some of the geological conditions may be responsible for that.
Yes.
Here also the water resource department is not have a good knowledge about the availability of the groundwater also. So it is a good topic here, because you see here we are getting around 4,500 millimeter of rainfall, but from October to March complete dryness is there.
Okay, so that means
That's
runoff.
why that the runoff, and also I have also visited Meghalaya and Cherrapunji. So many spring, you can see springs. No spring, there is no water. No perennial springs are there. Almost all the springs are dying because the start of October also. So that means it is a good topic, because in most of the forest areas, our agricultural lands are there, horticultural lands are there. So the farmers are growing horticulture crops like your oranges, khasi mandarin, and all these things. They are also complaining here, sir, in this dry period, because most of the lands are in the slopey lands, so orchards. So that's why this is a very good topic, sir. But you have covered almost all the aspects of groundwater and how to recharge groundwater for their springs. So very nicely, because I am also a soil and water conservation engineer. So it's a very good topic for me. I learned many things from this lecture. So I hope I can ask you some of the questions. But now we can expect some of the questions from our participants. If they want to have some queries, they can directly ask to our Ishwaradas sir. He's very, I think, done a lot of expertise here. So please, all the participants, you can interact with him. So after that only I can ask some of the queries of mine, and we'll conclude the session. Please, all the participants, please have a interaction.
Yeah. Please.
Sir, you can stop the screen sharing.
Yeah.
Can you stop the screen
Stop screen share.
Yeah, please stop.
Yes. Oh, dear participant, you can ask if you have any questions or queries. Yeah, sir. Sir, I have one query. Like groundwater availability and other its flow, it's not available to the public. I heard like that. And then sometime, people used to find the groundwater flow using some kind of magnetic. How best it is good, have a believe on it, whether it is works rightly, or I do not know. I want to get some information regarding this. And that
Exploration of groundwater.
exploration of
Traditional
groundwater.
methods.
Yeah, traditional method. Is it true how some kind of people have a magnetic field? My first question was like, the government nowadays, they don't want to reveal the groundwater sources to the public. Why? And the number two is how these people could able to find the groundwater flow using the traditional method. How best it is true? Yeah, these two questions, sir. Can you answer it? You can unmute and you can speak, because I given a privilege of unmuting the every participant. So please unmute and speak, sir.
So very nice question. Actually, this is a very practical question. Rather, you see, because now in the country, every state, I go. This is like my job, and people ask me a similar question. The first question is very pertinent. At NRSC ISRO also, we had a brainstorming session that the maps that are available in the Bhuvan, actually we have put the map for visualization or viewing, but actually you cannot download, because I get requests on daily basis from many people all over the country. Sir, this is my land, there is a problem, can I get a solution? The point here is, as you told, the requirement is at person level, because water, our body is 95% water. Everybody needs water, starting from drinking to agriculture. But to understand a scientific map, a state engineer or state hydrogeologist are trained. They can go to a location, they can find the source. Now coming to your the technique, that is locally what to use, or dowsing we call it. Even in United States and Europe also, those magnetic and giving with also giving success. I am not telling they will be always giving failure, but that science is yet to be proved. That is a science. That is science beyond science. Maybe the water, as I told you, I have experienced myself in a same kind of road. When I go from one patch to another patch, suddenly I will feel the area is little cool. And I know the water table is shallower here. That means when the water is found at some place, and when you are moving with some kind of a instrument, it will give you a kind of a feeling. But I will say, even I felt it, some kind of, the eddy current, or the kind of remnant current in my hand when I go with this iron rod and all. But that depends on the sensitivity of the body of a person. That is my understanding, if I go that way. So it is the sensitivity of that person of interpreting those feeble signal to get the knowledge about the water. So that's why, depending on the person, sometimes you are cheated, maybe the person is wrongly telling you, and sometimes they get a proper information. But coming to our scientific knowledge, you see, groundwater is governed by certain conditions. Means one is very important, is there should be very primary and secondary porosity. What is primary porosity? Means there should be good number of holes or the air space in the rock grains which need to be filled with water. or there are some secondary like fractures. The secondary porosity we call the cracks in the rock. Basically, in layman's term, it is the crack in the rocks you must have seen through which water percolates. But if the rock is completely one body, a monolith or a single mass, if it doesn't allow the water to enter, then obviously whatever technique you apply, water will not be there. That's why under our remote sensing technique, what we have done, we have segregated the areas where you have very less possibility of finding water, and you have more possibility of finding water by integrating those information. That's why if we combine the knowledge of a person with a scientific data, I have seen people are 100% successful in their endeavor. Those who understand this scientific knowledge, which are the possible areas where I should do the survey, then they go with this kind of conventional survey. They are more successful.
Sir, one more question, last question. So much thought about it. The usage, daily water usage from the ground level, the utility, say for example, one household, they may lift 500 liters of water. It is every day. There are, in the villages, so many household people who have that borewell. Like in South India, if you see that many, they depend on the borewell water for daily consumption and everything.
Yeah.
But what I feel the utility or this drawing of water from the well is more than this percolation or in the precipitation, like recharge, what you say that. So now, how we can make awareness to the people? It is going down day by day. People are like, if they're not getting water 400 feet, they are digging down again 500. But in foreign countries, as you are talking, like in Netherlands and all, 6-meter water level, they try to inject the water to maintain their water table in the ground. So what do you suggest, sir? Like in the situation, if it is goes for 10 years, it will be beyond recoverable rate, 10 or 20 years. So what would be the measures will be taken for this?
The best measure that I will suggest is always, as I told you in the beginning, you are earning 2 months and spending 12 months. That is for India water. See, in Netherlands, the rainfall in the entire year is around 650 mm. That is our semi-arid condition. But every day little rain happens. If you see their rainy days, it will not be less than 250. Whereas in India, it is around 50 to 60. That means there is heavy pouring of rainwater in few days. Intensity is very high. Duration is less. So water is going as runoff. So our objective is, as much as possible, we should conserve the water at its source where it is falling. So keeping the village boundary as our entity, the villagers should try to conserve their water in that village, from village to taluka, from taluka to district to state, then the country. So we have to conserve the water at its source in the best possible way. That is the only solution for our entire problem. Otherwise, we are going to face a severe war for water.
Thank you so much, sir. Thank you so much. Yeah, others, if you have any query, just
please,
you can unmute yourself and you can ask. Yeah, one more question, sir. There is a question here, which type of precautions are to be taken by the state government in fluoride high content area?
Yes.
So there is a question in the chat box. Can you read it and answer? There is
1 minute in the chat.
The chat box is there. I have read that one. In the chat box, if you click, it's there. Which type of precautions are taken by state government in fluoride high content areas? That was asked by Donta Murali.
Okay. See, this is a also, I mean, very pertinent question. We had a brainstorming session at ministry. I told them clearly, I go by very technical because my mind, because I am no, like you can say dreaming, eating, drinking, that is my 24/7 business to look at the water, especially groundwater and its conservation. I have told at the highest level that the all kind of processing that you do a fluoride, contaminated water, you are again going to contaminate it, because whatever residue comes, you will throw it somewhere, again it will leach into the water. Best way is, today you are extracting water, suppose fluoride is 1.4, you extract more, it will be 1.5 non-potable. So better to fence those areas, means we have to consider those areas and map those areas, and we should see that in the fluoride affected areas, I have told already people at the Jal Jeevan mission in the ministry level to bring water from the distance which are fluoride free and supply water to them. Taking a source within that village doesn't help. It may help you 1 year, 2 year, 5 years, but 20 years down the line, those sources again will be polluted. You will have a maintenance, high maintenance cost. And in India, if you look at in a longer duration, bringing water from a far off source in a long run of 20 years will be better than that, you are doing defloration at that particular point. That is my suggestion.
Okay, sir. Thank you. There, one more question is there. What is the cost of remote sensing, and government give any help? Asked by Guha Soyabali.
Different department, actually the pricings are different. If it is a government department, pricings are different. If it is corporate, pricings are different. If it's an educational institute, remote sensing data cost is very nominal. And why to go for cost? We have already, the government has decided below 5-meter resolution satellite data, you can freely download from our Bhuvan.
Okay, sir. One thing I want to ask, sir, as a hydrogeologist. So also in our college is near to Siang River, which is coming from Tibet, China. But why we are not getting water by having some bore wells? Many bore wells fail. So either without testing they have already drawn. So in state water resource department also we have requested. But what is the reason we are not getting water near to a river? So please, what are the possible reasons? Please.
See, I will give you a best answer to your question, because I have visited last year only ICR Mithun. That is in the, I mean, from your
Nagaland.
in the highway Kohima and Dimapur.
Nagaland.
So Nagaland, that ICR Mithun campus, same thing they told me. See, they are also near to one small stream. Water is not there from March to May, and Mithun such a big bulls. So they are very much starved without water. But problem is, I told you are in the sitting here in the water prospect zone. The problem is geology. They have not understood. Even their director contacted me. Their senior ICR, you have some in this one, no? What is that? Principal scientist and chief scientist, like that. The chief scientist also, he asked me, sir, what way we can go about it? We have given them a nice solution. See, I'll tell you one thing, Mr. Patnaik, I want to tell you, solution cannot be same for every place.
Yes.
Like you have to give the solution depending on the condition exist over there. When I went there, I had a thing in my mind when sitting in Hyderabad. But when I visited ICR Mithun campus, then I looked at their surrounding, their rock. I had a detailed understanding what they need. They have gone for borewells failed. In that condition, basically they are on river terrace. If you understand little of geology, the material that is brought from the hill, deposited in the foothill, and that river will cut those areas, so it made like benches. So all these ICR Mithun buildings, they are in different benches. but the material is more of clay and a little pebble. So that clay, which is not holding much water, they are trying to bore a well. I said bore well will not act at all successful here. I suggested them large diameter dug well, which can extract water from that stream level. You see, stream is flowing nearby, and water little or more are always there in that stream. So if your dog well can go below the level of that stream bed, automatically you will have recharge into the wells and good rainfall. I suggested some recharge structures and it is all working fine. But you need to maintain a open well or a dog well. You can't say, sir, dog well, something will fall, dust will come. Then, I mean, you need to do some kind of cleaning of water because dog wells covers should be there. But getting water in a borewell is difficult even if you are near to the stream because that material is not supporting the water to stay there. That is the major problem in ICR Mithun. Maybe I feel because you are near to river, you are telling, and since it is coming to the plains from the entire hills of Arunachal and coming from Tivar, so the material that is deposited in your campus may be similar to what I have seen in ICR Mithun. That's why your these wells are failing and bores you are not getting water.
Okay. Thank you, sir. If participants have no questions, any participant, any question, please?
Yeah, no problem.
Okay,
Another
we'll
10,
wind up.
15 minutes are there. They can ask me. I'm ready to, because this is what I do in the entire country. Try to solve the problem of people. If they have any query, I can address them.
So for our Pasighat, are you having any groundwater prospects map?
Pasighat, actually, we have that 50,000 scale detail because what I have gone to ICA and Mithun, we have done a 5,000, 10,000 scale detail mapping of that campus. That we have not for Pasighat. We have a 50,000 scale map for it.
Okay. Okay. So if no questions from the participants, now we'll. I thank. We are grateful to Dr. Ishwar Das for giving us time, and he has a lot of expertise in this groundwater hydrology and the application of geospatial technology. So we thank on the behalf of the college and Central Agriculture University to Dr. Das. So thank you, sir. We are ending this session here. Please, sir. Okay, thank you, sir. Okay, tomorrow.
Thank you. Thank you.
Friends, tomorrow again we'll meet for the another lecture. Okay. No, I see it. Okay, thank you, sir. Okay, thank you.
Thank you.
And